It's clear that the people, at least that I interact with at Applied Photophysics, understand that we are researchers and our brain doesn't always fit in a box, and then we want something that's slightly a little bit sideways. And they're happy to try to cater for that. I like that. My name is Dan Pantos. I am a chemist. I am a senior lecturer at the University of Bath, and I happen to be the head of organic chemistry here. We use the Chirascan for quite a few different projects. The main project, I guess, these days is we're looking at the interaction between small molecules that are chiral with quadruplex DNA. We look at the interaction between these small molecules and the quadruplex DNA in order to understand how the DNA is interacting with a small molecule, trying to develop an anti-cancer treatment. We use it for determining chirality, basically. We do a lot of melting curves, right? So when you change the temperature, so variable temperature, we do actually quite a lot. And we're looking at both the absorbance and the circular dichirism. We've looked in the past at linear dichirism as well. We're planning to do other things with it as well. So we're planning to do the FDCD as well. We're also using the Chirascan for looking at how cyanine dyes aggregate and how that influences their photophysical properties. So for that, we're using absorbance, CD, we're using LD, and then also now with the CPL accessory, we're measuring the CPL of these cyanine dyes. So these are the main things that we're doing. We have a project as well involving phthalocyanines, chiral phthalocyanines, and we obviously circular dichirism measurements for that as well. If you want to understand how chiral molecules interact with each other, circular dichirism is essential. You need to be able to study circular dichirism in order to understand how chiral molecules interact with each other. So the Chirascan instrument has been instrumental. Without it, for example, we couldn't really study how the G quadruplex DNA is changing its conformation as we add a denaturant or as we change the temperature. So without it, we would be kind of blind. Like this, we can actually see the interaction. We can see the changes in morphology because DNA itself is chiral. G quadruplex DNA is chiral, and therefore the Chirascan allows us to see this. So one area of research, for example, that we worked on for a really long time is called dynamic combinatorial chemistry. So here in dynamic combinatorial chemistry, you take small molecules. Our small molecules are always chiral, and you let them react with each other, and you can study how the molecules evolve and how they combine with each other to make some complex structures. So one of the biggest success stories of dynamic combinatorial chemistry that I've been involved in was to generate interlocked molecules, for example, like catenanes, or to generate molecular knots. Now, because all of our molecules are chiral, needless to say, these catenanes or knots, they are chiral themselves. We cannot study that and we cannot figure it out without the Chirascan, so without the CD spectrometer. So that's one success story, for example, that comes to mind. And we've made all kinds of interesting molecular knots, and hopefully there will be some more in the literature soon. The way how I see CPL, it's kind of like complementary to circular dichirism. So with circular dichirism, you study the chirality of a molecule in the ground state. With CPL, you study the chirality of a molecule in its excited state. So if you have a molecule that's emissive, so it's a fluorophore, right? And if that molecule is chiral, there is a possibility for that particular fluorophore to emit circularly polarized light. That is CPL. So then, what we're using the CPL accessory for is we irradiate the sample with linearly polarized light, because that's what the Chirascan produces. And then afterwards, we're looking at the circular polarized light that is emitted from our sample. Usually, we have the two enantiomers, right? So you have a left-handed and a right-handed. So then we're looking at the light that's emitted, whether it's circularly polarized left-handed or right-handed. So that's what CPL is used for. Nowadays, I think one can start looking at even more complex systems. And this is, I think, where my interest lies, because I'm a supramolecular chemist. That's what I like the most. And you can start looking at host-guest systems in which only one of them is chiral or only one of them is emissive. So can you study this interaction using circular polarized luminescence? So yeah, that's what we're using it for. A piece of research that hopefully will be published very soon involves some luminescent polymers, and we have introduced in these polymers chiral dopants. The polymers themselves are achiral, so they cannot emit CPL, but they are very emissive. So then we added chiral molecules to these emissive polymers that changes the morphology of the polymer in a thin film, and this thin film can emit circular polarized light, so it can have CPL. So we're using the accessory for that purpose. What I like the most about it is that we have the 4-cell changer, that we can change the temperature, we can control temperature with it very easily. It's all integrated, and the software, once a user is trained, the software is rather intuitive, and it's fairly straightforward to change things and then to be able to acquire good quality data. What I like the most about the CPL accessory is that I don't need extra lab space, because the CPL accessory goes straight into the sample holder, which I know for all the other makers, this is CPL manufacturers, I know that this is not the case. Usually in academia, the one thing that we fight the most about is lab space. So the fact that I don't need an extra lab space, to have a CPL accessory, that's excellent for me. And what I like about the whole system, the way how it works, is that I can put the CPL accessory and I can measure the CPL now. If I don't want to use today the CPL accessory, I can leave it in and then do my CD measurements as normal. But if I want, for example, to measure just fluorescence, not circular polarized luminescence, I take the CPL accessory out. It takes 5 minutes, and then you can record the fluorescence without looking at the polarization. So that's great. The CD data is of very good quality. The CDN absorbance is fine. It's working quite well. CPL inherently is very noisy. As it happens, I have friends that have other type of CPL accessories or spectrometers, and I have compared the data that was acquired on the Chirascan CPL with other manufacturers' CPL on the exact same sample, and the data is, I can't say identical because it's difficult to say something is identical, but it's very, very, very similar. Let's put it this way. So I'm happy with it. The customer service is very helpful, very useful. It usually happens very fast. If something is really seriously urgent, then I've picked up the phone in the past and I called people that I know are in customer support, and they help me solve the problem. The fact that we can do remote meetings and they can see the screen, or they can say, okay, unscrew this, plug in this, try that. That's actually very helpful. So I've done that with them quite a few times, and it's worked really well. So when I'm asked by colleagues or collaborators that are considering buying a circle diagram spectrometer, because of my experience, I give them the pluses and minuses of what I know. And I usually tell them that applied photophysics is reliable and it works well. So I always recommend it.